This video is on the objective generate a confidence interval using the empirical rule. And this is number 2. This is the second video on a question related to this objective in your Newton-Alta homework. All right. So again, if you're unfamiliar with the objective, please click on more instruction and read their material, watch the videos they have, take notes, and see if it helps you read their examples, see if it helps you work on these questions. All right. So we're given here the average number of chips per bag from the potato chips available at a supermarket is unknown. All right, so this is like the population mean. Right? If the population is all the potato chip bags at the supermarket, that mean, which we'll call mu, is unknown. And we're going to try to guess it. We're going to try to guess the average number of potato chips in each bag at this whole supermarket. Right? A sample, right, a random sample of potato chip bags from the supermarket yields a sample mean of, x bar equals 250.6 chips, right? So the average for the sample, the average number of chips in each bag for this sample of bags was 250.6. Assume the sampling distribution of the mean has a standard deviation, right, sigma x bar. Remember, this is the standard deviation of the means, the sample means for samples of whatever size sample was taken here, right, when they took this random sample of potato chip bags. This is the standard deviation for the sample means of all samples of that size. Right. And we're assuming here that this sigma x bar is 18.9 chips. Let's use the empirical rule to construct a 99.7% confidence interval for the true population mean number of potato chips. Right, what we're trying to guess, right? We're trying to guess the average number, the mean number of potato chips in the bags for the entire supermarket, right? The whole population. All right, so to do this, we're going to have to recall the empirical rule first off, right? That was that 68, 95, 99.7 rule. And also the central limit theorem comes into play here. So I'll refresh your memory as to what that is, what that says. Remember the central limit theorem for means. Remember CLT, central limit theorem, for a population mean. All right, now remember you have this population mean called mu, right? And this is the average number of chips for all the bags in the supermarket. And this is unknown, right? We don't know what this is. We're trying to guess what this is with a certain percentage confidence. And that's that 99.7% that they mentioned. That's our confidence level. Now by the central limit theorem, if I pull out we pull out samples of size n, you pull out samples of size n from the population, take their averages, their x bars, and then you look at all those x bars, all those sample means. Well, if the sample size is large enough, right, for maybe 30 or greater, or if the population was normally distributed, remember the distribution of all those sample means tended to be normal, with a mean called mu sub x bar, the mean of the means, and a standard deviation sigma of x bar, the standard deviation of all those sample means for samples of size n, with the mean of all these sample means equal to the mean of the population. But again, this is unknown. So we're going to use a guess at that. All right? We're going to try to guess mu. And the standard deviation, right, of all these sample means, remember, was the standard deviation of the population divided by the square root of the sample sizes. Now again, we're assuming here that they told us to assume that this was 18.9 chips, right? this was told to us, right? So, you know, I know we don't know sigma, we don't know n, but we were told that this value was 18.9. So now we're going to start guessing mu. So remember the initial guess. Right? The initial guess is our sample mean, and that's called a point estimate. The initial guess for a population proportion or a population mean is our point estimate, and that was our sample mean. And our this particular sample from the question, you know, had a mean, an average number of chips per bag of 250.6. So that's what we're going to guess here. We're going to use this initial guess as mu, right? Even though it isn't mu, I don't know what mu is, but we're guessing, and our first guess is our sample mean, 250.6. All right. And now I just need to figure out a margin of error to create this confidence interval that they're asking us for. Find a margin of error so that we'd be 99.7% confident in our confidence interval guess. All right, so I'm going to draw a little picture here. All right, so we're using the central limit theorem, right? The distribution of these sample means for whatever size sample we took is normal with a mean of 250.6 and a standard deviation of 18.9. So I'm going to draw that. So here's the different possible values of x bar, and the distribution is normal, right? So I'm going to create this symmetrical bell-shaped curve right above the number line there. And under the peak is our mean, our first guess at the mean, right? This point estimate of 250.6. And then if you recall, hopefully under the inflection points, right, the points where the curve changes from, you know, curving down to curving up or curving up to curving down, that one there and that one there, and again these should be the same distance on either side. It's symmetrical. Under the inflection points, right, those are going to be 1 standard deviation away. Now standard deviation for the x bar, as we said, was 18.9. Right, so this is 250.6, you know, plus 18.9, that'd be 268, 269.5. Right, 1 standard deviation above, and then 250.6, you know, minus 18.9, that'd be 230.6, and then plus 1.1, so 231.7. Those are values 1 standard deviation above and 1 standard deviation below our guessed mean here, our point estimate. And then we would go 2 standard deviations above, and then 3 standard deviations above. All right, so I'm just going to write this. Here's our point estimate x bar plus, you know, 2 standard deviations, so 2 times sigma x bar here. And then here's our point estimate x bar plus 3 sigma x bars, right, plus 3 standard deviations. Then we'd go 2 standard deviations below, 3 standard deviations below. So here's x bar, you know, minus 2 standard deviations, minus 2 times sigma x bar. Here's x bar, our point estimate, 250.6, minus 3 sigma x bars. Okay. And then we just have to recall what the empirical rule stated. Remember what the empirical rule stated was that the area under the curve within 1 standard deviation was approximately 68%, right? The area under the curve within one, you know, from 231.7 to 269.5 was about 68%, about 0.68 of the entire area. And then within 2 standard deviations was about 95% under the curve, right? And then within 3 standard deviations was about 99.7%, and that was the number that was given to us, right? We were asked to find construct a 99.7% confidence interval for the true population mean. So if I'm creating, now if I was creating a 95%, I'd do, within my interval would be these two values, the 2 standard deviations below and 2 standard deviations above. But we have a 99.7%, confidence level. So we're asked to create a 99.7% confidence interval for the true mean, right? For the mean of the population, right? For what the true average number of potato chips per bag is for the whole store, the whole supermarket. So that would be this, mu would be, we're going to guess that mu, right, the population mean, is between our sample mean plus 3 standard deviations. We'll figure that out. And our sample mean minus 3 standard deviations. Alright, so this is 250.6 plus 3 of those standard deviations, 3 times 18.9. And this is 250.6 minus 3 standard deviations, 3 times 18.9. Alright, and I'll pull a calculator up, what the heck. Alright, so 250.6 plus 3 times 18.9. So this upper bound is 307.3 chips. Right? Remember, this is numbers of chips in a bag, average numbers of chips in a bag. And the lower bound is the difference between those. So I'll just do second entry and then change the plus to a minus. And that's 193.9 chips. So what this is saying, what we're saying with this is, again, we're guessing the population mean. Right? So our guess, so what we would say is we're 99.7% confident. Right? So pretty confident. We're 99 based on our sample, right? Based on this sample with a mean of 250.6 chips per bag. We're 99.7% confident that the average number of chips per bag in the entire store, right, for the whole population is between 193.9 chips and 307.3 chips. Now that is a very big range, right? And again, the larger the larger confidence you have, the greater the confidence level is, the larger this interval is going to be. Right? But yeah, so that's what I'm going to enter, this lower bound, this upper bound. Now, if they wanted, say, just the margin of error, well, again, remember how a confidence interval is formed. You have your point estimate plus the margin of error and minus the margin of error. So this 3 times the standard deviation, that would be the margin of error, ME. Right? So we could figure that out. Right, what's 3 times 18.9? That'd be, 56.7. Yeah. So 56. So if you were asked for the margin of error, it would be 56.7, right? Because you got the middle is at 250.6, and you got 256 plus 56.7 for the upper bound, 250.6 minus 56.7 for the lower bound. But this 3 times the standard deviation is our margin of error. All right, but they just want the lower bound and upper bound. So we're 99.7 based on this sample. Right, based on this particular sample, we're 99.7% confident that the average number of potato chips per bag available at this entire supermarket is somewhere between 193.9 chips and 307.3 chips. And again, I'm right, and go look at again. See the minus 3 times 18.9 plus 3 times 18.9. Those 3's are z-scores. Remember the z-score? The z-score of a value in a normal variable, normal random variable. The z-score was just how many standard deviations away from the middle you were. And remember, this is 3 below, 3 above. Right? We're within 3. That's why they have z equals 3 here, z. All right. But yeah, so again, this is now my second problem doing this. One was with proportions, this one was with means, but the same concept though, right? To create these lower bounds and upper bounds. So hopefully that helps you when you're doing them on your own, and thanks for watching.